there are different aspects to reliability and validity. So typically in measurement theory, so what we use oftentimes in psychology is classical test theory, where measurement error is clearly defined, so to say, as random noise. So you have a true score, a person's true score. So if you could measure individuals' ability an infinite number of times with the same test, then there would be a distribution of the scores simply due to random noise. Not every measurement would be the same, and so you could just take the mean of that distribution. That would be the true score, so the best guess of that person's ability. And so then deviations from the true score, that's what's defined as measurement error. So that's one aspect that can be modeled in structural equation models, is random measurement error in the sense of classical test theory. And then also invalidity. So there's this issue of method effects, for example, like you mentioned, rater effects. When you have self-reports and other reports, they may not agree. So where is the true depression? Is it the self-report, or is it the other report that is better able to capture that? And so that can also be modeled with structural equation models that include multiple rater data, where we can look at convergent validity between different raters and model method effects as well. And so there are all these sources of systematic and unsystematic error that maybe in other sciences don't exist, where it just is in physics, it's just pretty clear what you're measuring. In psychology, it's not always so clear what you're measuring. And so therefore, psychologists are so concerned with reliability and validity. And so confirmatory factor analysis and structural equation modeling offer ways to address that by using multiple indicators. So multiple items, which basically is for repeated measurement. So like you mentioned earlier, so in order to determine reliability, we need to measure the same thing multiple times. And so oftentimes we do this with multiple items or multiple tests. And then we can determine to which extent those different items or tests share the same variance, so to which extent they're correlated. And so that's then what allows us to define a latent variable. And so the higher the correlation between the measurements, the more reliable those measurements would be, and the more variance in the latent variable, meaning the more true score variance.